Hi all, Des here again. Welcome to Lecture 10 of our Advanced Manufacturing Technology module. And today we're going to talk more about machining and toolpaths. And to best learn machining and toolpaths, we're going to wrap it around a project. So for the next video and next session or two, we're going to draw the geometry and apply the machining necessary to create the stool you can see in the image here. And last week we continued on our exploration of geometry, machining, we even did some engraving, and we made some edits to some machining and some toolpaths. So after those practice exercises, we want to wrap a lot of what we've learned and do a real life project. So the project we're going to start work on today is this stool, and it's made of a single top. It's the red component you see there. There's a pair of these lock keys, one on the bottom and one underneath the stool, and there's 4 legs. This is totally knocked down. There's no mechanical fasteners, there's no glue. It's just a matter of clicking the pieces together, maybe with a rubber mallet, and you've got a stool straight off the CNC. So we're going to start by drawing the geometry of that and then starting to put the toolpaths onto it. But before we do so, I just want to spend a few minutes exploring lead in and lead out options in AlphaCam. And moving over to AlphaCam now, you can see that the last time I was using the software, I was using it in 3D. So the little gizmo, the triad here, is in 3D. So to move to a 2D plan view of the bed of the CNC effectively, or to move to the XY plane, you can either press this icon at the bottom of the screen that says XY, or you could go View and then hit XY here. And now you should see the Y and the X axes will show me up the coordinates. I'll begin with just a simple panel, and I want this panel to be approximately the size of an A3 sheet of paper, let's say. So let's set the first coordinate to be 0, tab 0, enter, and the other coordinate to be 420, tab 297. Remember that a sheet of paper sized A3 is 420 by 297. I don't want that ghost tool yet, so I'll just tap Ctrl and G to get rid of it. And I'm going to use this as my sheet. So let's go to 3D, set material. Now I'm actually going to go to an ISO view. And it says pick geometry or solid, so I'm going to pick up the edge of that. The top will be 0, the bottom, let's say minus 18, and press OK. So there's the stock that we have to begin with. Geometry, rectangle. This time I'm just going to try and draw in 3D. I don't really like doing this because I find it hard enough to visualize where I'm going. So the first corner is going to be here. If you click, it'll allow you to draw the rectangle. So you could just guess it or could do it by eye. But if you go to rectangle and type in the first coordinate at, let's say, 50, tab 50, and press OK. The second coordinate then, let's make it, I don't know, say 150, tab 150, OK. So that's why I find it a little easier just to draw in 2D. At least it takes the Z direction out of it. So I want to machine that out. So let's very quickly go to Ctrl G to see the ghost tool. And I can see by default that ghost tool, the white arrow, is in alignment with the green geometry. So that's going to cut that green line with half the cutter inside, half the cutter outside. So I want to remove that all inside. So I want to maintain and protect my green geometry. So let's go to Machine, Tool Directions, and because this is a closed geometry, it contains area. We're not going to worry about the open geometries up here. We're going to only worry about closed geometries. And I want to go inside, and then simply click the green geometry. And when you click the green geometry, the white ghost tool jumps slightly inside. So press close. So what we can do now is go to Machine, select Tool. Remember, a lot of these icons will be grayed out unless you actually select a tool first. So select Tool, and I'm going to use the flat 10mm cutter. Double click it, it gives you a preview. When you're happy with it, you can either click or hit Enter. Now these commands come alive. That shows that there is a tool active. So I'm going to go Rough or Finish. Types, I'm going to leave it vertical for now. Geometries, I don't want all geometries, I just want selected geometries. That means I can, at the very end of this command, go and click the individual geometries I want to apply the tooling to. General, I'm happy enough to leave that be for now. Levels and cuts, let's set a safe rapid level of 40, that's 40 above the workpiece. Rapid down to is 5, that means the cutter will move quickly down as far as that height of 5mm before it slowly starts entering into the workpiece. Material top is 0, and let's say I'm going to cut all the way through, so the final depth will be minus 18. Number of cuts is 1. I want to do it all in one pass. This is just a practice exercise. Machining data, I'm happy enough to leave that be for now. We'll explore this in a future video. Lead in and lead out, however, is what I do want to explore today. So by default, you will have no lead in, lead out. That means that when the cutter comes down, it will just enter in line with where it's about to cut and then start moving. If I go apply auto lead in, lead out, you can see the graphic over here shows that the cutter will enter the workpiece somewhere, move in, start cutting, never stop moving, leave the workpiece, and then withdraw itself. It just means that if you've got a blunt cutter or a cutter that's prone to vibration or any other number of reasons, that you don't actually have the cutter drill down where it's going to be touching this green block in this case that you want to protect. So lead in is set to none and the lead out is set to none. So I'm going to set the lead in to arc, and you can change all the different angles and different things here depending on the type of material you're machining. But the arc radius, the size of the arc that it's going to take before it enters the workpiece here is arc radius 1. That means it's a single radius times the radius of the tool. So I'm actually going to make it 10 times the radius of the tool. I'm not going to bother changing the angle or anything like that. I also want the same lead out. Rather than duplicating the work, all the work you do on the lead in, you can simply press this arrow and it copies that to the lead out. So if I press OK, and if I now select this green rectangle or square and press finish, you can already see that there's this blue line showing where the tool is going to enter the workpiece, then it's going to move as a nice arc, pick up the actual tool path I want, run its course, and without stopping it'll leave the machining area, leave the workpiece. Let's run a simulation on that now. So view, solid simulation, and play. Now this is an error I seem to be getting with the student version actually. This usually won't happen if you are working on a piece of software that's already connected to a machine. I simply need to go to home, select post, and just pick one of the posts, pick a machine. It's something to do with the fact that it doesn't know the capabilities of the machine. So now if I press play, it should work. And you can see what it does there. It starts and it enters the workpiece over here. So if there is any vibration or any reason for it to move here, it's only going to damage or deform this waste piece of material. It'll enter the workpiece there, and then it'll not stop moving all the way around until it gets to the exit point, and then it'll remove itself. I'll stop that simulation. I'll go to operations. If you don't have the operations tab or any of these tabs, remember, you can go to view, show project manager page, and simply turn them on over here. And operation 1, finish pass, tool 3, flat 10 millimeters. I can right click that, edit it, or you can go right click, edit lead in out. It's the same thing. And here I'm just going to change the arc maybe to a line and feed that across and press OK and run the simulation again, or right click, edit, lead in, lead out. Let's change it to an arc again, but let's make the arc significantly bigger. So let's go to 20, copy that across, press OK. Now sometimes the speed, now this would have cropped up a minute ago had I selected the tool or selected the machine before I set the simulation. It's just very good at giving you feedback. Now I'm not too worried about this in this instance, but it simply tells me that the speed I've set for that tool is more than the post, more than that machine is able for. Because this is just a simulation, it's not important, but certainly I would pay attention to that if the cutter is set to move at a speed that the machine can't match or can't handle. I certainly would pay attention to it. I'd go back in, I would edit the tool. But for now you can see the simple edit I've made there. It now sends the lead in or lead out in a much wider arc. So you probably have already realized the problem with that. If I go to the simulation, so view, solid simulation, and press play, that's good and well if I'm not trying to protect the panel. It has machined out the block perfectly for me. But what happens if this is just a pocket I'm trying to protect and I don't want the groove there or the groove there? In fact, if I go to an XY view, you can see what I mean as well. If I run the simulation from here, as I press play, it takes a slot out of this, that curve, and it also takes the curve out of this. So you can see I'm trying to protect this green edge. I'm machining fully within this green line, so this arc actually does away with that. And there's a few things you can do to fix that. So I'm going to go back to an ISO view. I'm going to go to my operations and right click and edit lead in and lead out. And the first thing I can do is change it from an arc and change it to a line like we did a second ago. But the line length now in this case is going to be the tool radius by 5, or let's say even 4. So whatever your tool radius is, the length of the approach line is going to be 4 times that. And copy that across. If you wish, you can also click sloping, and that will mean rather than just drilling all the way down and then moving, it'll drill down slowly as it moves. So it'll start at the rapid down to level, and then as it moves into position laterally, it'll also move down vertically. So press OK there, and you can see a slight change has occurred. There's a little angle for a start, so it's going to start here and it's going to move down into position and start machining there. Another thing you can do is go to Machine, Tool Directions, and down here you can see Set Start Point on Closed Geometries. So if you click Manual, and if I click, say, the midpoint of a line here and the midpoint of the line there, if I press Close, sorry, I forgot to press OK. I did press OK actually, so it just hasn't updated. So I need to right click this and go Update. Now you can see this will be the start point. And if I press play now on the simulation and play, you can see the toolpath will begin inside, slope its way down, and then start moving around. And then rather than being confined at a corner here, I'm only damaging the material there. That will actually work if I go back to the operations, right click, edit lead in, lead out, change it back to an arc, but this time I'm not going to use something silly like 20 times the tool radius. Let's stick with 4 times the tool radius. Copy that across, and press OK, and now you can see, because the radius was so large a while ago, it had to start way off out here, but the radius is more reasonable now. It starts off just a little bit to the left and a little bit to the right, so it's still within the square. And it's always much better to start here in the middle if you're doing something like that. So let's go solid simulation, play again, and you can see now all the lead in and lead out happens within this waste piece, and I've protected the edge I was trying to protect, and I don't have a groove over here nor down here. So we'll do a little more with lead in and lead out as time goes on. It's just that I do want to apply these in the part of the stool project we're about to create. So you'll see them applied, you'll see them edited, you'll see them in proper use in a few minutes. So moving on to the main focus project of our lesson. It's a CNC stool, totally manufactured on the CNC and totally drawn and programmed for the CNC within AlphaCam. So it's got a number of different parts. It's got this circular red top with the cross cut in it. It's got 4 legs, all 4 legs are the same, and it's got 2 lock keys. There's a red lock key underneath the stool top and a red lock key at the bottom. And we're going to use a lot of features. You can read through them all there, but most of them we've already covered in our previous tutorials. Now it's time to apply them. And this stool was actually designed by a previous AMT Lecture student named Maurice O'Sullivan, and it's been run off several times already on the CNC, so we have all the troubleshooting and all the bugs knocked out of it, hopefully. So let's begin. So we begin with the stool top itself, and here are the dimensions required to draw that. So either take a screen grab or check the notes on Learn Online, but we're going to move over to AlphaCam in a moment and start drawing the geometry and applying the tooling necessary to manufacture this top. So in AlphaCam, I've just opened up a new file and I'm going to go to View and XY, so I'm looking at the proper view. What I'm going to do now is I'm going to use my 0, 0 coordinate and draw the geometry and move it where I want it afterwards. So to make things convenient, I'm going to go to Geometry, a circle, and I'm going to have a center and diameter circle. I'm just going to place the diameter at 350 because that's what the drawing said, and place its center at 0, 0. So 0, tab, 0, enter. And I know that's incorrect because 0, 0 means that some of it will actually be off the bed of the CNC. But I'm just going to draw it here for now, and in a few minutes I'll move it to where I need it to be. That ghost tool is confusing for the moment, so Control G to turn that off. I'm going to go to Geometry, turn on Construction, and go to Line. And turn on the snaps will allow me to draw a construction line from the top to the bottom of the circle. Just tap Escape and turn the line on again to go from the left to the right of the circle. Because if you look at your drawing, there's this crosshair, this cross that needs to be removed from the inside. And that crosshair's width is going to accommodate the vertical leg coming up, and the leg itself is 18 mil, so I need to make that slot 18 mil. So let's go to Edit, Offset. I want an offset distance of 9 mil, and I want to offset a line or an arc, and I want to offset it as geometry. If I don't tick Offset as Geometry, When I offset this in a second, it's going to offset it as construction lines, which isn't the end of the world, but I'm going to save myself a step by ticking offset as geometry. So this center line will be offset to the left, it'll be offset to the right, and this horizontal line will be offset up and down. And if you crunch the numbers and do the maths, you'll find that the distance from this line, the edge of the groove, over to the end of this vertical groove is going to be 116. So let's offset again a value of 116, enter, and I'm going to offset this green line over to the right 116 and this green line over to the left 116. And let's do one more offset, this time a vertical measurement of 125, press OK, offset this line up vertically 125 and that line down vertically 125. Okay, so now we need to trim away some of the excess. So if I go to edit, which I already am, and go to trim, select all and finish, I can just spend a couple of seconds trimming away what I don't need. So up on the top here, I don't need any of these lines. I'm not going to bother trimming my construction line because it's not going to get in the way anyway. And one more just at the edge there. And tapping escape, you can see I've forgotten actually to trim out the little bits in the middle, so let's do that again. So go to trim, all, finish, and just trim out those little pieces in the center too. Tap escape, you can see I now have the nice neat crosshair in the center that's going to be machined. Now if I try to machine this, first of all if I tap Ctrl G, you can see that there's a lot of ghost tools there, and I certainly don't need that many operations or that many passes. In fact, I just need two. I need a single one to cut the circle around the outside and a single one to cut out the cross in the center. So let's do what we'd normally do in this case. We'll go to join, we'll go all and finish, and that removes some of them. But I've included this example because it shows us that no matter how many times you join this, or even if you go to edit, or sorry, geometry in fact, special functions, common line removal, all, finish. Join resulting geometries, yes. If you have too many ghost tools and you've already done a join and a common line removal and there's still ghost tools there, it simply means there's stuff that needs to be deleted. So the obvious one is if I go to edit and delete, I clearly see that there's a couple of lines there, another pair there, and another pair there that need to be deleted. So let's go finish, delete all 6 geometries, yes. But if I zoom in here, those ghost tools have to have a bit of geometry or they wouldn't be there. So if I zoom in, I can see the tail end of that line is there. And that's a result of when I offset that purple construction up and I trimmed it, it just had a little bit sticking outside there that wasn't trimmed away. So I'm going to delete that, and then there's 6 more to do as well. So while I'm deleting those, I'll just explain that's a very good way to tell if there's little bits of geometry that shouldn't actually be there, that aren't going to be machined, because you could potentially run a toolpath or run a machine along them and it could ruin your piece. So let's delete that last one, press finish, press OK, and now you see it's perfect. Now I just have a single operation to machine the outside and a single operation to take out this notch, this cut there as well. So we're almost finished the geometry portion of this tool top. If you look at your drawing, the only thing that's left is to put a radius 3 fillet in those corners. And to help me explain this, if I go to machine, select tool, and let's use a flat 5mm tool. As the tool moves along and processes the inside, there's no way that round tool is going to get squarely into the corner. It will leave a fillet. In fact, if you don't want to apply that fillet, it'll be fine. This cutter will still move into the corner as best it can and leave the fillet. So you don't have to put the fillet there. The reason we don't have the fillet on the inside, it's an internal corner, because as this moves down and across, it is able to machine and process a sharp corner in that direction. So I'll just cancel that for a second. Let's go to edit and let's go to fillet. And the fillet radius is going to be radius 3mm. And I'm going to either go individual pick 2 elements, which is what I want. In some cases you can go all as set by ghost tool and you can select the entire loop and it'll actually put on the fillet everywhere for you. So it puts it on the outside and the inside. That's not suitable for my needs here. I'm going to press Ctrl Z to undo that because I do not want these internal corners filleted. So let's go to fillet, radius 3 and individual. I'll pick 2 elements. So you need to pick the lines in pairs and just make your way around put a fillet only on those outside corners. So now that that's done, that is all the geometry necessary to create that stool top. So just a double check again, just 2 ghost tools. That means there's no extra lines, there's no breaks in any of the lines, so ready to go. So we're going to machine this out now. And just before we do that, I'm going to go to Geometry, turn off Construction, and just put a temporary piece of material around that. We're going to make as many of these stools as we can out of an 8x4 sheet later. So we'll actually draw an 8x4 sheet, and that will be the block. So you don't need to draw this block around it, but I like to see the solid simulation to make sure that my machining works correctly. So I'm going to go to 3D, set materials, and let's set this material for its top to be 0 and its bottom to be -18. Now I know in the drawing we have it says -18.5, but that allows for the thickness of a coat of paint. So we're just going to leave it at -18 for now. And if I go to View and go to ISO, what I'll do is use this grey block to help verify and visualize my machining, and then I'll delete the block afterwards. You don't actually need this block for the machining to happen. So let's set the tool directions first of all. I'm going to go to Machine, Tool Directions, and I want to go outside. So this ghost tool, if I select this green geometry, needs to go outside, and this ghost tool, I need to select inside, click the green geometry and send that inside. And that didn't work, I'll just try that again. Let's go to Tool Directions, Inside, and click the geometry. And I jumped in this time. Actually what was happening there, it was picking up the manual option there, allow me to pick a different point. So while we're at it, in fact, let's just set the ghost tool to enter here in the center. So I've selected manual and selected the center point there, and this ghost tool is irrelevant. Let it enter the workpiece up at the top there. So press close. And now just to double check again, what I should have, 2 ghost tools, this one on the inside, this one on the outside. Let's now select a tool to perform the operation. So Machine, select Tool, a flat 10mm cutter, and let's just double check that that gets into the corner. And it does get into the corner, but it's not going to get tight into the corner to meet that curve we're after applying, but it'll do for now. You want to rough out as much material as possible with a large cutter. And what works great here is that this 10mm cutter will move up and down the 18mm slot or groove. It'll remove all the material. So press Enter. Now we can go to Machine, Rough or Finish, and let's go to Types. We want it to stay at vertical. I want to select my geometry. General, everything there is okay for now. Levels and cuts, we leave the safe rapid level at 40, wrap it down to 5, the material top is 0, and let's assume we're going to break all the way through. We could leave it to -18, or if you wanted to leave a skin at the bottom and take that last little bit off, you could set that to -16. It would break all the way through, or sorry, cut all the way through, but the last 2mm of timber would stay put. You'd have to trim that off with a scalpel or a router or a sander or something afterwards. So let's just say we're going to go all the way through in our case. Number of cuts, if that's 18mm of hardwood, you'd probably go through in 3 or 4 cuts. Let's say 4 cuts for now. If you wanted, you could have them all equal, or you could have them all a specific value based on the first and the second cut. For now, it's best for us to leave them equal. Machining data is okay. Lead in, lead out. Let's apply a lead in or lead out, and we'll see how this looks. We might have to experiment with this. So we will do an arc. Let's have it sloping, and the arc radius is just going to be maybe 3 times the tool radius, and let's copy that over and press OK. So I'm going to select this green geometry there and this green geometry there and press Finish. So now if I run the simulation, that should all be pretty good. If your simulation tab isn't open already, go to View, Solid Simulation and press Play. And it should start outside in the waste material with the lead in or lead out. It should machine itself all the way around, and it should generate this groove, this circular groove, in 4 passes. I'll just speed that up a little. And as soon as the 4 passes are over there, it will move in and it will start machining out the inside crosshair with another 4 passes. Okay, and that looks good. And you can see, because of this, the size of the tool, it leaves this small little island, this small piece of material in the middle there, and I certainly don't think that's big enough to cause any hassle. That would just fall away. If that was a larger piece that was going to come clear, I might use a larger tool in the center or use a technique called pocketing, which we'll get to actually remove that. But so far so good, that looks good. So the stool top itself has been protected. All the lead in and lead out happens outside it, and I have the geometry I'm after. So I'll press stop the simulation. And what I want to do now is run another operation. I want to run another operation that will get into those corners and tidy those up for me. So to do that, I'm going to go to Machine, select Tool, and if I had a 6mm cutter or something else suitable, I'd use it, but I have a flat 5mm cutter, which will certainly get into the corner of a radius 3mm. Now a flat 5mm, of course, is radius 2.5, so a 2.5 will certainly be able to get a radius 3 cut. So press enter to accept that tool, and let's go rough or finish again. Everything should be the same, but in the general tab I want to take account of previous machining. If I don't take account of previous machining, this cutter won't realize that this has already been machined. It'll just, in this case, if I do tick that box, just machine out the corners I'm after. So everything else should be pretty much the same. Levels and cuts will be okay. Now this is a very small cutter, so you might actually want to up the number of cuts, but it should be fine in this case. The smaller the cutter you go, the smaller the piece of timber you want to remove with every successive pass. So let's just press OK. And this time I don't need to machine the outside. That's already perfectly processed. I just want to machine this inside cross. So select that and press Finish. And you can see the busy portion of this newly coloured ghost tool, this operation, the red operation in this case, all happens at the corners. So there's no red tool paths in the centre where it's already been machined. And running the simulation again, I'll speed it right the way up first of all. And once it gets onto the crosshair, I'll slow it down just towards the end of it. So it's on the fourth pass now. You can see after the fourth pass what's going to happen is that tool will go and be changed, and the smaller tool will come in and just machine out those corners. So it'll allow you to get a much tighter groove in the corner there. So I'm going to stop that, and I'm going to do one final operation. The last operation is either to put a bull nose or a chamfer on the edge of the stool, the corner of the stool. I'm going to choose to put a chamfer on it. So I do have a chamfering bit, but I notice that the ghost tool is outside, and I want the chamfer tool to run along perfectly centered along this green outer circle. So to do that, I need to go to Machine, Tool Directions, and Center, and bring that ghost tool back into the center. And press Close. You'll note that this operation, the operation that machined out the circle in the first place, does not change. It stays where I put it, outside the circle, protecting that green circle, and that's fine. So if I go back to operations, I can see a little star and a blue colour comes onto this finish pass. If I wanted suddenly to take that operation and bring it back to align with the ghost tool, I'd right click and update that, but I don't want to do that. I want that operation to stay outside, and this new operation I want to follow the green circle there. Let's go to Machine and select Tool, and the tool I'm after is a VGC, a V-groove cutter 45. So double click that, that's the V-groove cutter I want here. So press Enter or just do a regular click and it applies the tool. So now it's just a matter of going to Rough or Finish, and let's go to Types, that's all okay. General, you don't necessarily have to take account of previous machining in this case, it doesn't usually matter. Levels and cuts, 40, 5 and 0 are all okay, but the final depth is going to be -8 rather than the -18 we had a while ago, and I don't want 4 cuts in there, I just want a single cut. Machining data and the lead in, all of that will still be the same, so press OK and select this green circle. So if you press Finish, you'll see another toolpath, another purple toolpath in this case applies itself. And because this V-groove cutter needs to run on the center of that line, that's why I brought the ghost tool in there. And to speed up the simulation, I'm going to go to my Operations tab and temporarily turn off the red operation, and that'll just speed it up a little. So if I go to View, Solid Simulation and Play, I'm going to speed it up while it machines out the 4 circles and the 4 crosses. And because I've hidden the layer of the operation that machines out the corners, it's not going to feature in my visualization, in my demonstration here. So it'll skip that, it'll move straight on, select the 45-degree V-groove cutter, and it'll process the edge of the stool like that. And you can see there's no need for that to happen in more than one pass. So that is the machining applied to the stool top. If I stop the simulation, and if I want to use this and save this over and over again, going to an XY, there's actually no reason for me to have this grey block. So I'm going to go to Edit, Delete, and click the edge of the block and press Finish. So I'm actually going to delete the block. Now remember, all the machining is still there. So if I go to a view and an ISO view, and if I run a regular simulation, the tool cutters and the tools will move around exactly as they did a few minutes ago. Let's stop that. If I go to a solid simulation and press play, it won't actually allow me to do it. You need to define a material in order to run the solid simulation rather than the simulation. So moving back to XY, what I want to do to finish off this stool is get the geometry and the machining applied for the top, for the leg, and the lock key all in one file, and then I can just take that and copy and paste or pattern it or nest it onto a sheet as I see fit later. So once the geometry and the tooling is done, you have the majority of the work done for the components. You can use them over and over again. There's certainly no need to go drawing the blocks and saving the blocks of timber around them. And as always, I'm trying to keep these videos to about the half-hour mark in duration. So that'll give you plenty of time to watch the video and also practice and draw along the exercises contained in the video. So we'll pick it up from there in the next lesson, where we'll draw the lock keys and the legs, and we may even get on to do some nesting. Nesting means that once we have the lock key, we have the top, we have the legs drawn, we can automatically fill an 8x4 sheet or fill a sheet of any shape or size with as many of these stool tops or legs or lock keys as is possible, or in the most efficient manner possible. So I'm not going to ask you to upload anything to Learn Online this week. I'm going to wait until we have all of the geometry and tooling for the stool finished. So please save your work from today, and we're going to open up that file next week, complete the file, and then we'll upload it to Learn Online. So we'll talk to you then.